Hi everyone, welcome to your help video for homework task 3. Don't forget to put your name. Now I'm not going through the actual questions for this one. I'm going to do questions that are very similar and then ask you to do the homework questions yourself. So the first one, instead of expanding 2 to the power of 4, I'm going to expand 5 to the power of 3. My working out will be 5 times 5 times 5, and either using my head or my calculator, that will be 125. For the next one, my question that I'm going to ask, that is very similar to this one, is 3 to the power of 6 times by 3 to the power of 4. Now this uses index law 1, where I know that if I've got something to a power and then I'm multiplying with the same base to a different power, I can just add those index numbers. So I'm going to do 3 to the power of 6 plus 4, which of course is 3 to the power of 10. So notice that what I'm writing on this sheet is not what you will write on your sheet. You will be doing the actual questions. I'm just doing a question very much like it. So do not just copy these things onto your sheet. In the next question, the question I'm going to do is going to be y to the power of 4 times y to the power of 7. This is similar to the question before, but I've got letters this time. So it's just going to be y to the power of 4 plus 7, which is y to the power of 11. For the next one, I've got division now. So I might do 5 to the power of 7 divided by 5 to the power of 2. So it's going to be 5 to the power of 7 take away 2. So my answer will be 5 to the power of 5. Similarly, in the next question, we're still dividing, so we'll be able to take away the powers. We're using index law 2. We've got something to a power divided by something to another power. We can simply take away the index numbers. This also looks like a fraction. It's the same thing. Sorry, that should be an n. So I will try x to the power of 9 divided by x to the power. I'm just going to leave x by itself, but we know that that's the same as x to the power of 1. So it's going to be x to the power of 9 minus 1, which would just be x to the power of 8. Now if I wanted to simplify 3 to the power of 4 to the power of 5, I can use index law 3. My power of a power law, which tells me that if I've got something to a power, and then I put it to the power again, I can multiply those powers. So this will be 3 to the power of 4 times 5, which is 3 to the power of 20. Similarly with letters, if I have y to the power of 4 and I give it to the power of 6, it's going to be y to the power of 4 times 6, which is y to the power of 24. Now, anything to the power of 0 is equal to 1, and that's our next index law. That anything to the power of 0 is equal to 1. We do have to be careful though and say to ourselves, what is it that is actually to the power of 0? So the answer to this one is just 1. But the next question, the thing that's to the power of 0 is this 2x, not the 3 though. So we need to make sure that we're doing 3 times 1, which is equal to 3. So it's only the 2 to the power of x that gives us, sorry, it's the 2x to the power of 0, that's the only thing that equals 1. These are our trick questions. So if I'd had 3y to the power of 4, I would have had to do 3 to the power of 4 times by y to the power of 4. 3 to the power of 4, you may need your calculator for. It's 81y to the power of 4. So on your calculator, you would have said 3, and then use your power off button, the power of 4, to calculate that that part of it was 81. When you've got things in brackets, so say I had 2/5 squared, that would be the same as 2 to the power of 2 over 5 to the power of 2, which is equal to 4 on 25, and that would be my final answer for that question. If I'd had p over q to the power of 4, that's the same as p to the power of 4 over q to the power of 4, and that would have been my final answer. as well. With our negative indices, so say I had 6 to the minus 1, that's just equal to 1 over 6. If I had 6 to the power of minus 2, that would have been 1 over 6 squared, which is the same as 1 over 36. I'm getting rid of the negative index and making sure I've got a positive index. I'm going to leave the tricky question for you. See how you go. I think you'll be able to do this one now. Maybe if I had y to the minus 3, I'll write that as 1y cubed. That's a similar question, but not the same question. And you do have to be very careful with these ones. If I had 5x to the minus 3, the only thing that's to the power of minus 3 here is the x. So this is the same as having 5 times x to the minus 3, which is equal to 5 times 1 of x cubed, which is equal to 5 times x cubed. That is a trickier question. So all three of those last ones are a bit tricky. Now for your scientific notation, I'm going to do a different example. So let's say I try a big number like 217300. So I know that I need to first of all make it into a number between 1 and 10. I'll make it 2.173, and I have to think about how many jumps I need to get from where the decimal point is at the moment to where it needs to be. 1, 2, 3, 4, 5. So it's going to be times 10 to the power of 5. It's a big number, so I know this number here has to be a positive number. Similarly, if I have a small number like 0.00341, I need to move the decimal place from where it is at the moment to where it can make this number a number between 1 and 10. So I need to move it to this spot here. So I'm jumping 1, 2, 3. So it's going to be equal to 3.41 times by 10 to the power of negative 3. Okay, it's a small number. I need a negative number. See how you go with the last ones. The mixture should be a mixture. Look through your books. If you're stuck, you might have an example somewhere like it in your workbook. Good luck with this.